Ladies and gents, my name is Brandon Stover. Welcome to the How to Solve Climate Change course from Plato University. Causes, systems, obstacles, solutions to this global challenge is what you're going to learn here today. When you're ready to learn more skills, join us for free at plato.university. Let's get started with today's lesson. We'll have our expert guests briefly introduce themselves and their credentials for why they are able to speak to this topic.
I'm Dennis Liu, Vice President for Education of the E.O. Wilson Biodiversity Foundation and the Half Earth Project. And I'm really excited about this opportunity to talk about biodiversity, in this case, not so much as a crisis or a problem, as in the extinction crisis, but actually as a solution for climate change. I trained in molecular genetics and laboratory science, but have spent over the past 10 years focusing on biodiversity, ecology, and conservation, largely inspired by the great proponent of biodiversity and our sort of leader and mentor, the late E.O. Wilson. Our current work for the Half Earth Project involves mapping globally where species live, where protected areas for nature are located, and where human impacts like urbanization and agriculture are most intense. So our work focuses on species and biodiversity and has important implications for buffering against climate change.
Explain succinctly what protecting biodiversity is from first principles.
The term biodiversity is used to refer to the many forms of life that exist on our planet. Sometimes when we say nature, we may think of a setting such as a lake surrounded by trees with plants along the shore, fish swimming in the lake, clouds in the sky. When we say biodiversity as opposed to nature, we're explicitly trying to get the listener or the reader to think about all the species that inhabit and depend on that specific place. So if the place is in fact the entire world, that means we have to think about 35,000 plus vertebrate species, the familiar animals of the planet, and probably at least 10 million total species of plants, insects, and other animals. So we want you to be thinking about all of the many species in a given place and the various ways that they interact with each other to produce a dynamic, functioning nature, the nature that provides us with clean water, breathable air, food, energy. We depend on these natural functions produced by biodiversity. Now, biodiversity is under threat by the various things that humans do, from mining to farming, various forms of industrialization, and including urbanization where we live, things that literally gobble up the natural habitat where species live. We propose at the Half Earth Project, and we show this on our Half Earth map, that protecting and recovering places where biodiversity is rich mitigates against climate change by specifically storing carbon in undisturbed grasslands and forests. So just by keeping these places intact, it mitigates against climate change. And these places are also home to myriad species. Furthermore, by keeping these natural places protected for the species that live there, the complex interactions between and among all these species produces a functioning ecology that further protects against climate change. It buffers against climate change. We also, given that climate change is going to proceed, even if we do everything we can to mitigate it, slow it down, eventually reverse it, it's going to progress for quite some time. So the more natural spaces we have available, the more living things can occupy those spaces and adapt, including, again, these important functions that they provide to buffer against climate change. So specifically, our climate change solution is to increase the current amount of land under protection for biodiversity from what's now 15% globally and also 15% by chance in the United States to 30% of land protected for biodiversity by 2030, with the ultimate goal of getting to 50%, which will get us into the safe zone, buffering against, protecting against climate change, and protecting enough species to keep all those important ecological functions intact. This can also include recovering, regenerating, and rewilding lands to get to this 50% goal.
Why does protecting biodiversity help to solve climate change?
The root cause of climate change is human activity. For good reasons, greenhouse gases have been emphasized, those produced by driving cars, industrial processes, the energy we produce to generate electricity for heating our homes and doing other things. These have been emphasized as the main cause of climate change and extreme weather disruption. The root cause of biodiversity loss, of the extinction crisis, is also human activity, primarily through the loss of habitat. So the clearing of land, again, for houses, for buildings, for forestry and farming, new roads, new towns, places where people live. Disturbing those lands can release stored carbon, contributing to climate change. Keeping those habitats intact prevents the release of that stored carbon, and it keeps the natural systems functioning to continue to store more carbon. For example, as trees continue to grow and maintain, and healthy soils are maintained.
Steelman the other side. Why would protecting biodiversity not work to solve climate change?
Yes, there are limits to how much protecting biodiversity can help to reverse climate change. Some restoration efforts, such as planting, regrading, fencing, other activities, do certainly require energy and therefore contribute in some small ways to climate change. There's some evidence, for example, that simply planting a lot of trees does not necessarily benefit biodiversity or help climate change. The most important first step we can take is to protect current wild areas, for example, mature forests containing many different tree species. When doing restoration work, it's important to do cost-benefit analyses. For example, if we're restoring an elephant population to an area, we have to consider potential human and elephant conflicts, along with various expenses to mitigate some of those conflicts, things like fences and other methods that may prevent elephants from destroying crops and directly hurting people. Conservation work can involve new roads and building all other sorts of barriers, and those things can be energy expensive and produce emissions that aggravate climate change. Although in the long term, such benefits would likely outweigh any costs. And importantly, compared to some of the things we're talking about to counter or ameliorate climate change, for example, implementing carbon capture technology, putting in place large-scale solar and wind arrays, for example, compared to those things, most biodiversity protection measures are much less energy intensive than those sorts of big capital projects.
Who benefits most by implementing the protection of biodiversity as a solution? Who is harmed most by implementing protecting biodiversity as a solution?
The most important thing to say is that if we really can reverse the extinction crisis and make our planet safe for the majority of species, for the bulk of biodiversity, all species will benefit, including the human species and the entire human population. In the long run, the entire 8 billion plus population of people on Earth will benefit from achieving the half-Earth goal. Now, of course, this population globally is very diverse. It's diverse in culture, various ways of living, and of course, in terms of economic wealth and how people earn their livings. So we have to make sure that our biodiversity and climate solutions don't further disadvantage, even temporarily, communities and groups of people that are already very challenged socially and economically. Although human activities that destroy species habitat do provide for certain human needs, they provide us goods and services, housing, jobs. It's not being done in a sustainable fashion. And in addition, most of this biodiversity and climate destroying activity actually benefits very few and mostly further enriches the already wealthy. So the potential upside of protecting land for biodiversity and to buffer against climate change is certainly going to have an overall positive benefit, including the generation of new jobs, new economies, new ways of looking at how we use the land and gain value from the land. And I think we need schemes and plans to make sure that in the transition to a more sustainable ecology on the planet, those who might be temporarily disadvantaged are somehow taken care of, whether that's help supporting alternative ways of making a living, helping them to live with nature as opposed to the current dominant concept that somehow we have to be apart from and against nature in order to make a living on the planet.
How does protecting biodiversity work as a solution to climate change?
The Half Earth Project calls for protecting half of the Earth's surface, the lands, the waterways, the oceans, protecting half for the rest of nature. That's a big increase from the current 15% that's under protection. So that's the simple essence of our solution, is to go from 50% global protection for biodiversity to 50%, which is going to have a huge knock-on benefit for countering climate change. We have lots of evidence that when you take specific conservation measures aimed at protecting species habitats, you in fact can succeed in saving species and even make some progress toward reversing the extinction crisis. The Half Earth solution is unique in that it calls for an overall goal for all of these conservation efforts, which understandably are typically locally focused. So if we can add up all these conservation efforts toward a big global goal of half, we're going to get into the safe zone and have a sustainable ecology that we all depend on, all species depend on, including the human species. Now, because life on our planet is not evenly distributed, some places on Earth are home to many more species than others, including rare, endemic species, range-limited species. So we need tools to prioritize which places should we focus on for protecting first. And part of that solution, part of our solution, has been to develop the Half Earth Map, which is a freely available digital tool that presents the priority places on Earth to protect. Now, this priority protection layer of the Half Earth Map provides a common framework and what I'll call an evidence-based starting point for making what can be difficult conservation decisions. Now, a map user can also look at the layers, the data that we've used to make this priority layer. And those critical layers are: where do species live? What are the patterns of richness and rarity of biodiversity? What are the patterns of intensity of human impacts, agriculture, mining, forestry, urbanization, as well as the locations of currently protected areas? So, for example, in some cases, you may have adequate protection in a biodiversity-rich area, and it's not a priority to have increased protection. But in many other cases, if you can add protected areas adjacent to already protected places like national parks, you're going to get a magnified benefit from that. So all of these factors are considered in making the framework for prioritizing where we should protect first. Now, in addition, we've now added a layer to address the climate benefits of protecting biodiversity, where we show where the priority for biodiversity protection layers, that layer, we add a layer that shows where the best payoff in terms of carbon storage and climate change reduction also will take place. So there's not 100% overlap of these areas, but there's an amazing coincidence between these areas that are rich in stored carbon and also valuable for protecting biodiversity. Now, the second part of this is, of course, we need people to actually use this tool. And that's where we're trying to make a movement culture and be an umbrella and platform for the many, many organizations who are working in this. And we can be a place to showcase their important work and to actually measure progress toward a stated goal, which will contribute to both reversing the extinction crisis and buffering against climate change.
For protecting biodiversity to work, what innovation or policy needs created?
Well, for our solution to work, we need innovation in schooling and learning, things like this course, because we need to start now, but we need to stick with it for quite a long time. And although, for example, overall climate change has been a long and frustrating road, currently overall awareness of the problem of climate change is pretty good. In the case of biodiversity, there's actually much less appreciation of the biodiversity crisis and how dire it is, and very little understanding that actions we take to support biodiversity also will help ameliorate climate change. So we need innovation in communications. We need creative thinking on policy. And then, of course, we need the action of people who know how to persuade policymakers. There's also room for creative market solutions in the case of climate. Some of these market solutions have been difficult to implement, things like carbon, cap and trade for carbon. And there's some concerns that can encourage, we'll call it bad players, to simply try and pay their way out of the problem. I think we can't give up on these market-driven solutions, and therefore we need innovation, both in how those markets will work and in communicating to people how they work and why they're important. Then we need innovative partnerships for restoring, protecting, and working in private lands. I've really been emphasizing things in the policy arena, for the most part, permanently putting lands into protection for nature and biodiversity, things like state parks, national parks, land trusts, which are private, but they function in a corporate way. But there is also a role for individual landowners and more community-based, more local conservation activities, things like Doug Tallamy's Homegrown National Park, which I'm on the board of, is a great example of trying to rally private landowners to take action that will support biodiversity. And many of those actions trying to get less lawn, which is a monoculture and often very chemically intensive to maintain, which means energy and water intensive, trying to get some of those lands converted back to habitat that can store carbon better and protect biodiversity.
For those that are interested, what are the best 2 or 3 resources you could point them to?
First and foremost, of course, I would like to point folks to the Half Earth Project, and that's half-earthproject.org. Easy enough to find if you just search for it. And in particular, visit the Half Earth map, which is a interactive three-dimensional globe that gives you an incredible view of the whole planet in terms of where do things live, where do we have protections in place, where are human impacts most intense, and therefore where are our best opportunities to protect current wild lands and consider restoring some lands. It really is an engaging tool that allows you to see global patterns, but also zoom in to high resolution to look at highly local circumstances. You can look at parks, places, neighborhoods, even that you're particularly interested in. Another important affiliated website is the Map of Life, mol.org. That is our data team, which is based at Yale. And of the same data that you can find on the Half Earth map is also available on the Map of Life. In some cases, you can get more detail on specific species. And you can also look at more metrics that people use to measure the state of nature, in a sense, measures of how well we're doing to protect nature around in different places around the world. Another really good resource on understanding biodiversity and linking it to climate is NatureServe. So that's one word, serve, serve.org. They have excellent data and information on biodiversity and species protection, including a recent, really excellent report on the United States in particular. A final organization that I would recommend people to check out is the World Resources Institute, WR.org. They're a sort of a data consultancy that looks at all sorts of important aspects of the environment in terms of global challenges. So they look at food systems, forests, water, energy, climate, urbanization, and including from an economics lens. I would also like to include Doug Tallamy's books, Bringing Nature Home, Nature's Best Hope, and the new effort called Homegrown National Park, all one word, homegrownnationalpark.org. That's a great place to learn about what you as an individual person can do to help contribute to protecting biodiversity. There's also so many good podcasts out there. I would check out podcasts of rewilding.org. They're really excellent.
Right now, you're speaking to passionate students who want to actually solve problems like these. What top 3 skills should they study so that they actually have the ability to do so?
Top 3 skills that someone needs to do this work, which I'll define as protecting biodiversity. First of all, I think it's important to say we need all sorts of people to be engaged in this. It's a big global effort, and it's an effort that has to be sustained from this day going forward. So we need all sorts of people involved in it. So as long as you're passionate and reasonably informed about the topic, I think you can really make an important contribution. I will say, for the work we do at the Half Earth Project, the E.O. Wilson Biodiversity Foundation, one extremely important skill is to understand evidence and how evidence is analyzed in order to prioritize making decisions. So traditionally, we would think of this as a scientific skill, but I actually think people bring this skill of weighing and analyzing evidence from all sorts of disciplines, of course. So I think being analytical is an important companion to being passionate. Currently, digital mapping skills, GIS, is also extremely useful and important in this work because we're talking about spatial analysis, protecting, literally evaluating places on the planet and proposing ways to protect those places. There's lots of ways to get trained in GIS. Our partner in this, Esri, offers free courses and resources to learn how to use these tools. And people like maps. Maps are engaging. and can be very persuasive ways to show information as compared to showing someone a spreadsheet or a table or a list of numbers. Seeing things on a map is easy to digest, and it can be very persuasive. And then I would say sometimes what's called soft skills, the people skills, are extremely important. So if you can combine being passionate with being analytical and versed in tools, modern information tools like digital mapping, GIS, if you can combine that with people skills, and I mean all those aspects of communicating well, of understanding, being empathetic to people's concerns, to understanding different people hear things differently. They bring different background to it. You have sort of diplomatic skills and a knack for, in some ways, simplifying messages, but also understanding how to try and communicate with different individuals and audiences in different ways. That can be really helpful, because conservation is really it's based on science, hopefully, but it's based on persuading people to do something or to support something. And so the human dimension of this is so important. And therefore the ability to communicate is an invaluable asset in this arena.
Any final recommendations for the audience?
I'm so happy to have a chance to give a final ask to the audience here. I talked mostly about our project and our effort to protect half the planet for the rest of nature. I didn't talk in detail about my main role in this effort, which is education. And I work mostly with teachers, college professors, high school, middle school teachers, because to support them, to find ways for them to engage their students in this in our mission. And but I'm also very interested in reaching students directly. So I'm eager to connect with college students, especially find out if there's ways through various university, college clubs and organizations, if there's ways to connect directly with people. I'm really interested in that. The Half Earth Project has an educator ambassador program, which if you search Half Earth Educator Ambassador Program, you'll find a place where you can sign up. Now, for the most part, I've reached out to classroom teachers and professors to sign up to be ambassadors, but I would love to have students doing this directly. And I would say the most important thing you can do to help us is just to spread the word about the biodiversity crisis. Again, there's fairly wide recognition of the climate crisis. And in some ways, a lot of people have sort of chosen their side, that they're either interested and engaged in doing something about it or not. Biodiversity in some ways is a fresh way to talk about the way we're treating the planet. And so I would just encourage you to go ahead and speak up with your friends and your family, and to find gentle ways to make this part of your regular conversation, that we should care about all the other species on the planet and the impact that we're having on them. And the fact that protecting those species can help all sorts of environmental concerns, including climate change. And I would encourage you to do it in as easygoing and gentle a way as possible. I think that's the best way to infuse this thinking more broadly, and to just overall generate more awareness, which will make our work easier, both doing the actual work, fundraising to do this work, influencing politicians as we do this work. So thanks again so much for listening.
Let's bring biodiversity protection closer to home. Identify local ecosystems in your area like forests or wetlands. Map out the ecosystem services they provide and discuss how their protection can enhance climate resilience. Consider writing a letter to your local city government advocating for their protection.
Thank you for taking the How to Solve Climate Change course. If you want to learn the skills to solve this global challenge, join us for free at public.University for exclusive content, extra resources, and actionable exercises with every lesson. This course was produced by Plato University, where students turn passions into purpose and learn skills to change the world. Learn more at plato.university.